Okay, let's solve LeetCode 139 word break. So we're given a string and a dictionary. So if we split the string into two or more words, then those words should be there inside the dictionary. So we have LeetCode and we can split that into leet and code, and each of these words should be a part of the dictionary. So my initial solution was, since we have our string, we can check each part of our string, that is the substrings, and we can see if that exists in the dictionary. So we'll start with L, LE, LET, and then we'll check that in the dictionary. And if it exists, we will reset our running string, and we will check the remaining part of the strings. Okay, so the first thing we'll do is we will set our running temporary variable, and we will go through all the values inside the string. Now we will add each value to the temporary variable. Okay, so now we also need a hash map which will have all the values inside our word dictionary. Now we are going to check if our temporary variable is there inside the hash map, and if it is, we will reset it. Now we will check if the temporary variable is equal to nothing, we will return true, otherwise we'll return false. Okay, so clearly we have had an error over here, so we'll figure out why that is. Okay, so the reason why we are having an error is because we can see here we have 4 A's and 3 A's in our dictionary. So what we are doing is we're checking each value one by one, right? So if we have, first we will take 3 A's and then we'll check it with the word dictionary. So it exists, right? So we'll take the 3 A's. Then we will do the same thing again and check the 3 A's, and if it exists, is there. But the problem is we have this last A which does not exist inside our dictionary, and hence we got the output as false. But what we were supposed to do is we were supposed to have 4 A's and then taking a 3A, or taking a 3A and then 4 A's. So the output should have been true instead, as expected over here. Okay, so first what we can try is we can try brute forcing it. So we'll check the first 4 letters and we will match it to whether it is the words in the dictionary. So if we have lead, we will check it, and if it matches, then we'll concatenate and we will get the remaining string. Since code does not match with lead, we will return false. Similarly, we'll do the same thing over here. Okay, so let's code the solution. So first, this is a recursion problem because we are using brute force. So we'll start with defining a function that takes the arguments of a string and a dictionary. Now we will check each word in our dictionary, and if the word exists in the first part of the string, we'll take the rest of the string and we will put that back into our recursive function, and then we will return true if that is correct. If it's equal to the word, then we will check again if we get the function back, if we get the call back returned. From the start of the remaining word to the end of the word. And then if this is true, then we have to of course return back true to the other ones also. Okay, and now if this is actually not working, if none of the words are actually getting correct with that string, then we will return false. Also, we need a case where the string is empty. In that case, we'll just return true. Now I will just call this function and return it. Okay, but this is actually not the optimum solution because we are not using any memorization. So we'll just add some memorization to the same core problem. Value. Okay, so that is my memorization. Now I'll check if s is in memo. If s, the string, is inside our memorization map, then I will return the value of it, which is nothing but s memo of s. And then we're also going to use memorization in this false statement to memorize whether or not it was false. So now if we solve this again, yeah, our time has reduced by a lot. If we submit this, now here we have used memorization and it is dynamic programming, but it is not as memory efficient as we want it to be. So we'll try using bottom-up approach to make it more efficient. So right now I changed the words because it was actually getting a little bit confusing with the A's. Okay, so what we're doing is we have this string, right? And now we're doing a bottom-up approach. So we'll set the final string, I mean like when the string is empty, to be equal to true, and we'll go backwards from that. So we'll start with this E. Now E is at position 7. In index 7, if we add one of these two words lengths, so 4 and 4, if we add 4, then clearly it's becoming bigger than this whole list, right? It's greater than this whole list. So we won't do anything and we'll go back. Similarly, 6 plus 4 is clearly greater again, so we'll go back. 5 plus 4 is also greater, right? 1, 2, 3, 4. It won't work. So 4. Over here, we have this CODE, right? So from this 4, if we add 4, we will end up in 8. Hence, it is lesser, it's equal, lesser than or equal to this list. So 4 plus the value of this, I mean the length of this current word, 4. And then we will see from here till here. So from code, CODE, from 4 till A, 4 till 8, so CODE, and we will see if these two words match. So leet and code clearly don't match, right? So we will do the next word and code is there. So now code and code match. So we will set this to be equal to the value which we initially got, which was 4 plus the value of this word, which is nothing but 4, and we get 8. So we will set this to be equal to this. Now we'll go one step back again. Similarly, we'll do the same thing for T. From T, we have we can add 4 and we'll get 1, 2, 3, 4 until this D, right? So why we are taking 4, I'll explain. It's because we can only match it with 4-letter words. So we are taking this 4 over here, and TCOD is clearly not equal to leet. So we don't have to do anything. And same thing over here. Even TCOD is not equal to code. So we won't do anything at 3. Now we'll go back to position 2, position 1, and clearly we'll clearly not get, because ETCO will not work, EETC won't work, but LEET. Now if we add 4 over here, 1, 2, 3, 4, right? We have we have we have leet to be equal to leet. So we will set this value over here from false to true. And now the final value is going to be the value of this zeroth term. Okay, so now let's code the solution. Now initially we need a list, right? That is to be set to false. So I'll create the list and I'll set all the values to be equal to false. Now I'm adding 1 because we need the final value to be equal to true, right? When the string is empty. And now I'll set that to be equal to true. Okay, so now I'm going to go through all the values in the string backwards. Okay, so now I'm going to see every word in my word dictionary, and if if the index of that word plus the words I mean length is greater than this whole list, then we will set then we will not do anything. So we'll keep it lesser than or equal to this whole list. So now I will take each and every word in my word dictionary, and I'm going to match it to that letter. So from the index I will add the words length, and then I will see whether or not it is greater than this list. If and I want to make sure it's lesser than this list to proceed to my statements. Okay. Okay, so now what I'm going to do is I'm going to take the specific index and I'm going to add the length of the word and check if it's equal to the word. So, and word, and this should start from the specific index, right? Okay, so now I'm going to set the value of that specific index in our list to be equal to the value of that word which was there over here. So okay, now I also said that if we get the value to be equal to true, we have to break out of this loop, right? So we'll just set that if and now after doing all of this, the final answer should be over here. at position 0. So we'll just return that. And if we submit this, so we can clearly see even the memory is pretty good.